All right, welcome back to lesson 4.2. We are continuing on with special product patterns. So some of these I've talked about before, but I haven't stressed it just because we didn't get to it yet. So what it's saying is if you have two binomials where A is the same number, B is the same number, and you have a positive and a negative, you could simply do A squared minus B squared. All right, so example right here. So same x values, same number. If you have a square of a binomial, so if you have something like this that's being added, you can take your a squared, then do a times b times 2, and then b squared. And the only difference with the negative is your middle term would be negative. The important part, though, is when you have ones like this, notice that the 2t was squared, the whole thing. So that's how they got 4t squared, because they squared not only the t, but also the 2. All right, and cube of a binomial. So if you have a plus being raised to the third power or minus, this is the pattern that you're going to use. So while we're on this, I did want to show you that cube of a binomial is actually on your Algebra 2 reference paper under cubic functions. That's the only one that they give you. But I just wanted you to know that it is there. So if you come across that, you have that. You don't have to have that one memorized. So I will give you this one on a test as well. All right, so let's dive in. We have a 4n and a 5 and a 4n minus 5. So if I look at that, that one tells me it's a sum and difference. So I could rewrite it as a squared minus b squared. So let me identify my a value. Let me identify my b value. So my a value is 4n, and my b value is 5. Remember, we don't care about the signs because the sign's going in the pattern. All right, so because if you square a negative 5, you're going to get positive, but it has to be a negative in the pattern. All right, so we're going to say we're doing a squared minus b squared. All right, that's the pattern we're going with this. I'm getting it from right here. So in my a spot, I'm going to put 4n, and I'm squaring it. Notice I'm squaring all of 4n because that is what a is, not just 4, not just n. Minus, and then we're going to square b. All right, so refresher, that's what I was saying. I don't know why they don't go over these rules beforehand. Anytime you have, let's just say 2x raised to the a, so that a has to go to both. So the 2 is raised to the a, the x is also raised to the a. All right, so you have to distribute this exponent to both. So this becomes 4 squared. All right, 4 squared, which is 16. So we have 16n squared minus 25. All right, and that's your answer. That's all you had to do. So we're not even doing much math. The only math I did was square 4. The rest came from the pattern. All right, so let's look at this one. We have something being raised to the second power, and there's a subtraction in between, so we have square of a binomial. So we're going to use the pattern a squared minus 2ab plus b squared. So let's identify our a and our b. So our a is 1.4y, and our b is 2. Again, we do not care about the sign because the sign is in the pattern. So I'm going to plug in my a. So I got 1.4y, and that is squared, minus 2 times 1.4y times 2, and then plus 2 squared. And now I just need to simplify. So 1.4 squared gives me 1.96. So I got 1.96y squared. 2 times 1.4 times 2 gives me 5.6. And then 2 squared gives me 4. And so then that would be your answer. All right, so again, only math I did was I squared my 4, so make sure you're given, or 1.4, so make sure you're doing that, and then make sure you multiply all 3 of these together. That was minus already, or the negative, so that's why I brought that down. All right. Last one. So we have AB plus 4. So they love to throw crazy things like this in there for you. So which one does that match up with? It matches up with the cube of a binomial. So we're going to take this and we're going to put it in that pattern. So we're going to say a cubed plus 3a squared b plus 3ab squared plus b cubed. Hopefully Miss Gill can fit all of her stuff in here, but we shall see. All right, so what is our a value? This is why I find this so weird. Our a value is ab. Like, why wouldn't you do like xy? No idea. What is our b value for? I just feel like that makes it a little confusing. So if this one confuses you about the a, b, change it to xy and try it that way. I think that's what I did last year, and I forgot that I did that last year. Okay, so now we're going to plug in our a is going to be ab, our b is going to be 4. So I'm going to go through here and plug in all of that. I'm not going to make you watch me. So I'm going to pause the video on my end. So you may want to pause it on your end so you can substitute the a and the b's in. I did run out of room, but it's okay. All right, so this does not stay like this. You do need to distribute that cubed to both variables, so it becomes a cubed, b cubed. So this one, the square is going to go to both of those. We have a 3 and a 4 that we're going to multiply, so that becomes 12. And then we have a squared, b squared. All right, then the AB, we don't have to do anything with it. We do have 4 squared. So we're going to take 4 squared, which is 16, and multiply that to 3 and get 48 AB. And if you want to do one of these where I show a little more work, I'm fine with that. And then 4 cubed, 4 times 4 times 4 gives us 64, and that is our answer. So if you want to see like a step from here in between to see how we exactly got those numbers, just let me know. I will more than happily show you. So those are some examples of the different patterns. So you have 6 different types. Notice we only did 3. So we did do one of each section. So hopefully that helps. All right, last one, Pascal's triangle, everybody's least favorite triangle. So Pascal said he came up with this triangle. The triangle is right here. What the triangle does is it relates to any perfect square or any binomial that's raised to a power greater than 2 or greater. And the binomial expansion is shown here. So basically what he's saying is, in the past we would have taken this and said a plus b times a plus b times a plus b times a plus b. So we would have had to do 3 multiplication problems in one just to get this answer. So instead we have this Pascal's triangle. It tells us that we can use this pattern right here. Miss Gill has always struggled with memorizing this. I've always just done it the long way on anything important, but now that we have this, I'm going to use it. Just know, say, because Pascal's triangle is not on your reference paper, so say you get a question like these, you can always just sit there and do 3y plus 1 times 3y plus 1, get that product, and then do it one more time. All right, so just know that that is an option. It's a long way, but it will get you the same answer. All right, so let's start off strong. We're going 5th row, so x minus 2 to the 5th power. All right, let's identify our a and our b values. So our a is, oh, I did that off the paper a little bit. So our a is x, and in this situation, the negative does matter. Because notice these are all plus signs. So in this situation, it does matter to make our b -2 instead of just 2. All right, so I'm going to write this row down on my paper here to match up. All right, so I've got the pattern written down. So now what we're going to do is everywhere there's an a, we're going to plug in x. Everywhere there's a b, we're going to plug in -2. So pause your video and do that now because I'm going to pause. Odd exponent that is with, what did I miss? I missed something. How do we go from b squared to b? Oh, I totally missed this term. All right, Miss Gill's got to fix this. Maybe not. Maybe I haven't lost my mind after all. All right, so let's simplify. This one just becomes x to the 5th. All right, next one becomes 5 times negative 2 gives us negative 10x to the 4th. So that's what I was saying. So since the exponent of this one is 1, that gives us a negative value there. All right, so now we got 10. So we got negative 2 squared. So negative 2 times negative 2 gives us 4. 4 times 10 gives us positive 40x cubed. Negative 2 to the 4th power. Did I write? Okay, that 2, 3. I did miss one. I missed the 2, 3 one. Hold on. I'm sorry, guys. And I'm showing you what I'm fixing. I told you, I'm not a huge fan of Pascal's triangle. I just have to teach it to you. So I did leave out this second one. So I'm going back and adding that one in. So because I left that out, I'm going to erase these last two so I can do that one right there. I knew something wasn't right. Sorry, I just really don't want to start this video over. Okay, so I'm going to now, you should have the 10 times x squared times negative 2 to the 3rd power, and so on. Okay, so back to this. So we got negative 2 cubed, so negative 2 times negative 2 times negative 2 gives us negative 8. Negative 8 times 10 gives us negative 80, and we have an x squared. Now we got negative 2 to the 4th power, so that is going to give us positive 16, and 16 times 5 is going to also give us 80. So we have 80x, and then our last one is negative 2 to the 5th power, which would give us negative 32. So, and then this one is the answer. Yes, that is crazy. I know. I feel you too. I don't know that I've ever taught this and people are like, oh, I love Pascal's triangle. Nobody likes it. But nobody it is quicker than sitting here doing x minus 2 times itself 5 times. So it's definitely quicker than that. All right, so I want you guys to try B. So pause your computer. We are doing the 3rd row and try substituting that in. All right, so I have the pattern written down. Our A value is 3y. So this one's not going to be as easy to zip through with the x's. So we may have to pause and work out some of this from time to time. So if you have this, and now go back and substitute in your A and B. All right, so this is what it would look like with all your values substituted in. So remember, we have to distribute that 3. So this becomes 3 cubed y cubed plus 3 times 3 squared y squared times 1 plus this one kind of stays normal. 1 squared is 1, and then 1 cubed is 1. All right, so now we can simplify this. You cannot leave it like this. So 3 to the 3rd power, 3 times 3 times 3 is 27y cubed. Then we have 3 squared, which is 9. 3 times 9 times 1 is going to also give us 27, and we have y squared. 3 times 3 is going to give us, times 1 is going to give us 9y plus 1. And so there is your answer to that one. So I did forget to highlight this one for you. All right, so Pascal's triangle, again, they love to put one of those questions on the test, though. But like I said, if you have a test and you forget the triangle, you can always do it the long way. Or maybe you'll remember this pattern at least, and you could go from here and then continue on. All right, guys, that is the end of lesson 4.2. It is a little bit one of the longer lessons in the chapter. So please give it your best effort, ask questions in class, and I will see you guys in class.